To sketch the bifurcation diagram, I need to know the fixed points and their stability, and I need to get them onto this diagram. My differential equation is x dot equals g of x minus r. I don't have an algebraic form for g of x, but I know it's this curve that's shown here. Fixed points are going to occur when x dot is equal to 0. So that's when g of x is actually equal to r. So I'm first going to try a few values of r and think about what happens if g of x is equal to that r, and create the phase line at that value of r. I've just drawn in the r equals 0 line. Fixed points occur when g of x equals r, so I have 3 of them. 1, 2, 3. Let's see, this one's at -1, so r equals 0. There's a fixed point here. This one's a little below 1, and this one's a little above 1. Then I'd also like to know their stability. G of x is greater than r, so x dot is positive in this region, so my arrow goes that way. Let me add that arrow. And then in this region, g of x is less than r. Positive, negatives, stable, stable, unstable. So for now, I could sketch them in over here kind of as some scratch work. Stable, stable, unstable. Now let me go to a different value of r. I'll set r equals 1. Again, fixed points occur when g of x equals r. So there's just the one fixed point. And drawing in the vector arrows, I find that it's stable. Okay, and it's happening when r equals 1. So that's r equals 1. And the stable fixed point's down at -x. It's down here somewhere. Now let me think about reducing r from 1 down to 0. So this line would just be shifting downwards. There's a saddle node bifurcation when r is, I don't know, about 1/3. This fixed point persists. It's actually going to be stable the entire time it exists, and it's going to exist all the way until r is down, way down here at approximately -2. So I'm just going to draw in between r equals 1 and r equals 0. This branch is this branch, and this stable fixed point is born up here at that saddle node, and this unstable fixed point is right there. Then I'm going to fill in the rest of the diagram. The key thing to determine is when this next saddle node happens. It happens when r is approximately -2, and when x is just about -1/3. So -2, -1/3, I draw it in. I connect this branch up. I connect this branch up. And now, once I erase my scratch work of the green and purple dots, I have the bifurcation diagrams. It's showing where the fixed points are for each value of r and what their stability is.